In the question, they are saying that both Earth and Moon are subjected to the gravitational force of the Sun. We know that our Sun exerts gravitational force of attraction on each and every object present in our solar system. So the same case holds over here. That is, as we know that this Earth and Earth and a Moon, they are also revolving around the Sun. It will also exert, that is, Sun is also exerting the gravitational force of attraction on Earth as well as on the Moon. Now, as observed from the Sun, the orbit of the Moon. Now, they are asking us to depict the orbit of the Moon when observed from the Sun. See, when we observe from the frame of reference of the Earth, we know that this Moon revolves around the Earth. This Moon revolves around the Earth, and it takes 28 days to complete one revolution. Okay, Moon takes 28 days to complete one revolution around the Earth. So this was with respect to the Earth. When I talk with respect to Earth, the path, that is the path, the orbit of the Moon is elliptical or it is approximately circular. But this was the case when I talked about the when I observed from the Earth. Now, if we observe the path of the Moon, that is, if we observe the orbit of the Moon from the Sun, then it would be different, because we know that it is somewhat complicated, since we know that Earth revolves around the Sun. Earth revolves around the Sun, and it takes 1 year to complete one revolution around the Sun. And we know that not only this motion of the Earth is not as this simple. It is not only revolving around the Sun in the elliptical orbit, but it is also rotating along its axis. Okay, rotating along its particular own axis, and with along with rotation and revolution, it is performing its motion around the Sun. But we know that this Moon, it is also moving around the Earth in a particular orbit, and the orbital velocity of the Moon, is same as the angular velocity of the Moon. Okay, angular velocity of the Moon, so that only one face is visible for us every time. Whenever we see Moon, only the one face of the Moon, one side of the Moon is visible to us. So, moving further here, as we know that in the 28 days, Moon takes 28 days to complete one revolution around the Earth. Then, in that 28 days, this Earth will move some distance farther. It will move some distance on its orbit. The Earth will cover some distance, some amount of distance on its elliptical orbit, on its orbit. So as the Earth will move forward, and it will cover some distance in the 28 days, then the Moon has to change its path, and the Moon has to travel some complicated path to to take one revolution around the Earth. So that complicated path is displayed over here. You can see that this black colored curved path indicates the orbit of the Moon. This indicates the orbit of the Moon, and this circular path, this green color circular path, indicates the orbit of the Earth. Here for ease, for our ease, I took the orbit of the Earth circular around the Sun, but it is actually elliptical. Okay, so when it is, we know that the orbit of the Earth is elliptical, then this orbit will of the Moon will also be it will also be directed in the elliptical way. So for your ease, I have drew in this way. Okay. So we know that any planet, when it is under the influence of the gravitational force of the Sun, it will move in the as the gravitational attractional force exerted by the Sun on the planet. It is a central force. It will move in the elliptical orbit. Okay, coming so due to that reason, the Earth is also moving in the elliptical orbit around the Sun. So coming to the Moon, that what happens over here is other planets present in the space will also exert some amount of gravitational force of attraction, but those gravitational force of attraction exerted by the other objects are very weak compared to the gravity, compared to the force exerted by the earth and by the sun on the moon. Okay, so now the moon is under the two dominating forces, that is gravitational force of attraction due to earth and gravitational force of attraction due to sun. So when the moon is, as we know that the moon travels and follows a complicated path to take only one revolution around the earth. It travels some complicated path is like this, so that it will be able to complete one revolution around the earth in 28 days. So well, during that motion, what happens is the moon is so we know that the gravitational force of attraction acts on the moon due to the gravitational force of attraction due to the sun on the moon is always directed towards the sun, that is towards the center, and the gravitational force of attraction due to the earth on the moon is acting randomly. Okay, so here it is acting in this direction. The gravitational force of attraction due to earth is perpendicular to the path, and gravitational force of attraction due to the sun is always directed towards the center. And we know that the gravitational force of attraction due to the sun on the moon is twice the gravitational force of attraction due to the earth on the moon. So, as this larger force is directed towards the sun, then the net resultant gravitational force of attraction on the moon will also be nearer to the will also be directed. The net resultant attractional force will also be directed nearer to this force. Okay, so from the vectors you might be familiar with that concept. So what happens here over here is, so what happens is, as the moon, the total gravitational force acting on this moon is not strictly directed towards the center. It is directed it is directed not towards strictly towards the center, but it is around the center. Okay, it is not towards strictly center. Like it may be around the center. It may not point exactly the center. So due to this reason, what happens is, as the net resultant gravitational force of attraction is not acting towards the center exactly, it is not pointing at the center. Due to that reason, as observed from the sun, the moon will not follow the strictly elliptical path. Okay, so it will not follow the strictly elliptical path. It will move in approximately elliptical orbit. Okay, in this type, so that so when I see the path observed from the sun, the orbit of the moon will not be strictly elliptical, because the gravitational force on it, total gravitational force on it, is not central. Okay, so our option B is true. Coming to option A, it is wrong. It will not be elliptical, and we know that it is not elliptical, but will be necessarily be a closed curve. See, as this net resultant force acting on the moon is not towards the is not exactly towards the center, but it's approximately nearer to the center. So as it is approximately nearer to the center, then the path will be approximately elliptical. It is not strictly elliptical, but it is not strictly elliptical, but it will be approximately elliptical. So option C can't be true. Coming to option D, it deviates consider the orbit of the moon as observed from the sun. The orbit of the moon deviates considerably from being elliptical due to the influence of the other planets other than the Earth. So actually here this is also not true, because we know that the dominating forces acting on the moon is only the gravitational force of attraction due to the sun, and the gravitational force of attraction due to the earth. The other objects present in the space are the force exerted by them, that is gravitational force due to them, will be very weak, will be very much less compared to this. Okay, as the distances are very large from the moon, and their masses are very small compared to the sun, so their force of attraction is considerably, they don't show any kind of influence. So our option D is not true.